Bill, go ahead and introduce yourself, and I will fade into the background here.
Okay. Well, thanks, Alicia, and welcome everyone in New Westminster and area. Now, I used to live in New Westminster on London Street. That's not far from the high school. So there I live. Oh, and also someone else was there too. Bear. Yeah, Bear lived there too, didn't you? You lived on London Street? Yeah, 900 block. Yeah, that's right. Bear lived there too, and oftentimes there was a big picnic table in the backyard. So Bear and I would go out at night and look at the stars, didn't we? Yeah, and sometimes though the neighbors would phone and say, "Bill, did you know there's a big fierce bear in the backyard?" And I would say, "You got the wrong number," and hang up. And then Bear and I would laugh and laugh and laugh. Quite funny, didn't we, Bear? Yes. Okay. Bear's going to be helping me out throughout the program because Bear is also a stargazing expert. So I'll draw on his knowledge to assist me from time to time. Okay. You have a seat there, Bear. Okay. So the first thing we have to know about the sky is what it looks like. And the sky is, when you think about it, it's a giant ball that's up over our head. And I just happen to have such a ball. Here it is. There's my sky ball right there. So this is what the sky looks like. It's a ball that goes all the way around, and we're sitting right in the middle. Now, what do I mean by that? Well, if we look in the middle of this ball, we find the Earth. There's the Earth right there. Right? So the Earth sits in the middle of a big ball. And on the surface of the ball are the planets, the moon, the stars, and comets and shooting stars, whatever else you see. It's called the celestial sphere. It just means a big ball. Now, if we took the ball and made it collapse so that it was flat, then we'd have a flat, round piece of sky, which would look like this, a star map. So this is a star map right here. And on the star map, we can see what are called constellations. So constellations are groups of stars that make pictures up in the sky. So sometimes they're animals, sometimes they're people. Sometimes they can be made with a fancy, like a product like this. Other times they can be homemade, and sometimes we do that. The black line here shows you the ground so that we see the part inside the black circle. And as the time goes on, we see different parts of it. So in different seasons, we see different pieces of the sky. In the summertime, we see the summer stars and the bright star Vega in the Harp. In the fall, there's a great square of Pegasus. In the winter, we see Orion the Hunter, and so on, all the way around the sky. Now, the homemade one I mentioned is this one right here. It's got two circles. This is the star circle, and here are the constellations. There's Hercules, right? And Deneb and Vega and Altair over here, the summer triangle. So these are some of the stars we see in the summertime. To make it easier, there's two sides to this disk. And this one just has the simpler stars, the ones that are easier to see. Right now, the constellation of the Lion is in the sky. Leo the Lion, there's the lion right there. And he's coming up, and going down is Orion the Hunter, who's right over here. So Orion is traipsing down. And how this works is that we have a star finder, and it has the times of day on it. The disk has the days of the year. So when one is slid into here, I often refer to this as loading the software into the hardware. There's your software. So plop, in it goes into the hardware. And now we just turn to the time and date. So today is March. We're looking at March, and it's the 18th of March. So I take the 18th, and let's move it around to the evening time. We'll pretend the sun has gone down. So it's say about 9 o'clock. So at 9 o'clock, this is what we see. In the south, the Lion, right? And in the west, down is going Orion the Hunter. So he's just collapsing in. And there's the Gemini twins with the bright stars, Castor and Pollux. So this shows the stars If you want your own planisphere, the easiest way to get one would be to go to the website of the National Research Council in Ottawa, and they have a online version of this. So you take the cursor and move the cursor, and then when you do that, you see the thing rotate on the screen. Or you can print out one from some source and then make a photocopy of it and then cut it out. So that's how this was made. I took a file folder, and that makes the so that it's not floppy like a piece of paper, it's stiff. So the back of a file folder with staples and scissors and cutting out the disc, I made my own star finder. So it's really simple. You don't need a lot of cost or money or things like this to get started with astronomy. It's really not like skiing or polo ponies or something like that. It's really an inexpensive thing. Things made with paper, little tools and things like that. We can get started on astronomy right away. Okay, so the celestial sphere is sort of the map of the sky that we can see. But the question is, when are interesting things happening in the sky? And I put Bear to this to do some research on this. So Bear, have you decided what are the 10 best things to see in 2022? Are you going to share them with us? What do you mean, no? Come on, Bear, come on. We're this is the New Westminster Public Library. We have to be cooperative. Okay, he's changed his mind. Oh, he's giving me something. This is the top 10 things to do in 2022 with the stars. So let's see the list here, Bear. Yeah, and don't be silly. Just sit over there and don't make a nuisance of yourself. Okay, in 2022, according to Bear, this is what's happening. At the end of the month, around the 31st of March, we will see Mars, Saturn, and Venus very close together in the pre-dawn sky. So before you get up in the morning, you look outside, you can see 3 dots really close together, and those are the planets Mars, Saturn, and Venus. They're very different planets. Saturn is a gas giant planet. It has a ring around it that you've probably seen pictures of. The ring can be seen well in small telescopes, and Bear and I have seen it very many times, hundreds of times. Mars is very different. It's a terrestrial type planet, but it is cold on Mars, and it has a little a blemish on the top, a polar ice cap. So Mars has got frostiness on the top, but you couldn't really ski there. There wouldn't be like a Whistler there or something like that, because the frost is very thin, so there wouldn't be very good skiing if you went there. No. Okay, Venus, much different again, the opposite. It's very hot. So Venus is covered in a thick atmosphere. All the heat and light from the sun is trapped inside, raising the temperature of Venus to very high. So one very hot planet, Venus, one very cold planet, Mars, and a gas giant planet will all be visible at the same time. Venus is the brightest, Mars is second brightest, and often orange in color, whereas Venus is colorless and kind of white. So that's the end of this month coming up. Before you get up to go to school, when the break is over, check out the 3 planets in a row. Now, the second item chosen by Bear is the Leonid meteor shower, which is on April 21st and 22nd. So what you do is go outside and you can see shooting stars flying through the air. It's probably best to get to some place where there's a minimum of city lights and interference from cars and things like that. Now I know it's it might be difficult, but if you go to some place in New Westminster where there's a lot of open grass, that is the best place to sit yourself and wait for the shooting stars. So they will come April 21st and 22nd. Up to 15 can be seen per hour in a nice dark sky. So look for the shooting stars. They're not really stars at all. They're bits of rock and dirt that enter the Earth's atmosphere, fly through the sky, and then burn up. Although sometimes they make it through the Earth's atmosphere and it can be picked up. So this is one of them here. So this is a rock that came from space. It's a space rock, right? So this entered the Earth's atmosphere, flew through the sky, glowed red hot, and then landed on the ground, and someone picked it up and gave it to me. So it's a little bit unusual because it's not like a regular rock. It is very heavy. So if you put it in your hand, you'd be surprised how much it weighs. So it is the weight of a piece of iron of the same size. So it's kind of heavy. Yeah. Okay. The third one is April 30th, right? And it's a non-blue moon. Well, this is kind of a weird one, isn't it? Well, I'll have to explain this. Bear, this is a weird one. What happens is a blue moon is 2 full moons in the same calendar month, but a non-blue moon is the new moon twice in a row in 1 month. So what happens on the 30th of April, there will be a new moon, and it will be the second new moon of April, but you can't see it because it's right next to the sun. So what happens is we have to wait until the moon moves a little bit away. So about 3 days later, you'll see a narrow crescent moon in the sky in the west as the sun goes down. And that will remind you that the non-blue moon has just passed. Okay, the fourth one is the one that's getting quite a bit of attention. It's a total lunar eclipse, May 15th. Okay, now what happens? Well, I've got the moon and the earth here. Oh, in duplicate. This is not the real moon, the real earth. There's the earth right there, and there's the moon. Now, in a lunar eclipse, the moon moves into the shadow of the earth, right, and disappears. So now we can't see it very well because it has no sunlight on it anymore. So on the evening of the 15th of May, the moon will rise, but instead of looking like the bright, shiny full moon that we're used to, it will be a dim, pale, reddish, brown, or something like that moon, and not very charming or alluring, I suppose, unless you notice that it is very, very different from the regular full moon. Now, the difficulty with this one is it begins as the moon rises from New Westminster and in Western British Columbia. So we're not going to see the full thing. It will be seen in its entirety if you live in the east. So I'm doing another Zoom with another library soon, and that's in Thunder Bay. In Thunder Bay in Ontario, it'll be a lot different because the moon will then rise before the action starts. So in Thunder Bay, Ontario, they'll see everything, right? But I have to give a little bit different explanation when I'm talking to Thunder Bay than I do in New Westminster, right? And the reason is, if you look on the Earth, see, we're on one part and Ontario is over here. So there's a curve in between. So the moon is hidden from us while it is rising and getting eclipsed, but it's visible from Ontario. I don't know. Why does Ontario get all this good stuff? I don't know. But never fear, because what will happen is as the eclipse ends, then we'll see the shadow of the Earth go back across the moon, and the moon will become full moon looking and very, very bright and in glorious display. So that's something to look for on the 15th of May. Okay, so the fifth item of interest is a super moon. It's not a super duper moon, but it's a super moon. Full moon. This is June 14th. Now, a full moon, a supermoon, is when the moon happens to be a little bit nearer in its orbit to us, so it looks a little bit bigger, but it's not dramatic. It's not like, no, it's not like that, not like that, no. It just looks a little bit bigger, tiny bit. You probably won't notice anything. And really, astronomers don't take their telescopes out when the moon is a bit closer, because it is just a bit closer and doesn't really show any more details. There's another complication in that the mind exaggerates the size of the moon anyway, right? That's why the moon looks jumbo size when it comes up at harvest time, right? The harvest moon, right? It'll always look bigger when it's low to the ground and smaller when it's higher up. But that is a psychological effect, the way we interpret information that we see. So it's not a real effect of the moon. And instruments that measure the moon do not find that this effect at all. This also operates on constellations. If you see a constellation low to the ground, it will look bigger than the constellation higher up. But again, this is how we interpret the world around us through the senses that we have. Okay, that's 5 down. Bear, have you got the rest? Okay, here's another one. June 24. Planets alignment. Ooh, yes. Well, you see, the planets go around and around the solar system. And as they do that, they sometimes line up in a row when they're close together. Right. So, I mean, from our point of view, they're really far apart. But at dawn on the 24th of June, looking towards the east, we'll see Mercury, Venus, the crescent moon, Mars, Jupiter, and Saturn all in a row, all in the same part of the sky. So this happens from time to time. If you have a telescope, Mercury is kind of hard to see, but it looks like a pink dot. Venus has phases. The moon looks moonish, right? It'll be a crescent moon. Mars is a little tiny berry with a white sugar on top. Jupiter is, well, I think we have a picture of Jupiter here. This was taken by Bayer many years ago. And now we see, this is Jupiter. And Jupiter has 4 moons right here. There's 1, 2, 3, and 4 is right there. So these 4 little dots are the moons of Jupiter. To capture them, Bayer had to overexpose Jupiter. It looks like that with stripes on it. Maybe I should get a crayon and color that so it looks sort of Jupiter-ish. Right, so the moons go around Jupiter and can be seen in small telescopes. Yes, so that is the planet alignment of 2022 in June 24th. The next event will be the Perseid meteor shower, which is in August 12th to 13th. But it's not really a great one this time because the full moon is nearby, and the full moon will disguise the light of the shooting star. So it's not a most favorable, but Bear thought he'd mention it because if he didn't, then some people would complain saying that he was doing an incomplete research, right? And then they make fun of him, stuff like that. So that sets Bear off. He can start growling and things like that. Or he might even overturn a garbage can and eat whatever's inside of it. He's done that quite a few times too. Neighbors don't like that, but there's nothing I can do about it. Okay. Total lunar eclipse, another one. Yes, this one's in November 8th. Now, this time we get to see the eclipse and the Eastern people don't. So that's pretty good. November 8th, Western observers only. It's before dawn. So what it means is that the moon, the full moon, will be in the western part of the sky, and it will be sinking down, getting lower and lower and lower. Right, but it will still see the whole eclipse. If you're in Ontario, though, remember, on a different part of the world, then you'll miss the eclipse. So we get to see it. So just as the first one, we were sort of a little bit ripped off. This one, we're going to see the whole thing, and the East won't get to see it. That's why I have to tailor my remarks depending on what part of the country I'm talking to, because I've given these talks all the way from Vancouver Island to Newfoundland and Labrador. So different things will happen in different parts of the country because the country is so big. If I was a community astronomer in Luxembourg or Belgium, then it would be much different since the country's tiny. Okay, so after that, we've got Mars opposition December 8th. Okay, what this means is Mars goes around the sky, round and round, so does the Earth. Every once in a while, the 2 orbits intersect and they get close to one another, and Mars looks much brighter. So around early December, it will look like a very bright berry, right, stuck in the sky, and sort of orangey in color, or maybe slightly red. Although I've often found it's more golden in color than reddish. So it's called the red planet, but that's really it's not that accurate a description. It's more orange. It should be called the orange planet, but I have no there's no one you can write to complain, right? Okay, so that is, most of the information about Mars we've gathered in these close approaches. The approaches of 1877, 1956, and 1971 were very fruitful for gathering research about Mars. But we don't need to rely on this now because now it's possible to put things on Mars and find out, or around Mars, and have things that are automatic devices find out things about the planet Mars. But you have to remember, no people have been to Mars. All right, so these are machinery that are set on Mars to take pictures and things like that, but people haven't gone to Mars yet. So the only place that was visited was in space was the moon, and that was by the astronauts in the 1960s and 1970s. But no one has been that far away into space since December 1972. The Apollo 17 mission was the last one to the moon. Okay, finally, drum roll, the last of the 10 best things to look at in the sky in the year 2022 is the Geminid Meteors. December 13th to 14th are the Geminids, but again, bad luck. The moon is nearly full, so the moon is going to disguise some of the shooting stars. But again, Bear thought he would mention the Geminids because they're getting to be more prominent now than they have been. So the meteor showers, they come and they go. It's almost like a fad, right? But rather than like moving from hula hoops to something else, the fads in the shooting stars are that basically some streams seem to run out and then they're not as exuberant with shooting stars. Others continue or increase and they get to be better. So right now the Perseids are the top, but it could be in 10 years the Geminids will be just as important. Anyway, those are the top 10 items to see in the year 2022. Well, Bear was earlier showing me some of the things that he's been doing that have to do with his art project. But you didn't know that Bear has an art project going. Yeah, isn't that right, Bear? Yeah. Are you going to share with us your art project and show everyone what you're doing? No. What do you mean? Yeah. No. We want you to say yes. Say yes. Okay, he's saying yes. Really, Bear. Okay, this is part of Bear's artwork. Let's have a look here. We'll grab the grab this. Okay. Oh, okay. So this is interesting. So Bear drew this in the garden. There. So does that look nice? It's a dahlia, the flower. Yeah. But Bear, the topic is astronomy. Right, this is what we're doing today. It's astronomy in New Westminster, and you're showing me a picture of a flower. Do you have anything like starry? Okay. Oh, okay, here we are. This is Bear's drawing of the moon. Here he is. There's the moon. Now we've got space stuff. Thank you, Bear. What Bear did was he made a drawing of this tree with the branches, and then went out with his telescope and made a drawing of the moon. You can see there's some craters over, let's just move about back here. Oh, here we are. There's some craters over here. The moon has these round features and there's shadows within them. These are the craters in the moon. Sometimes they're dark and sometimes they're light, like this one. The moon also has dark patches on it that make shapes. So what Bear did was he took a peanut butter lid and put it on the paper, and then he drew the outline of the circle. That's going to be the moon. And then he went outside, looked through his telescope, and carefully recorded all this information, and then drew the tree around it just to give it some sort of context and just make it look a little bit more interesting. So there's the moon. And often people ask me, how does Bear make these moon drawings? I mean, we all know he's a very smart bear, but how does it work? I'll show you. This is what Bear does. First of all, let's take a look at the moon in its. There's a photograph of the moon, and we can see that there's dark and light patches on it. Well, first thing to do when you're making a moon drawing is to draw the outline of the dark patches, like that. And that is what Bear's done. Here we are. So this is Bear's drawing, and there's the real moon. So you see how they're alike? So that was the first step in making the moon drawing. Then the second step is to color in the dark areas. There they are there. So then we color in the dark areas, and then finally we add more details, including areas. There's little numbers on the pictures, and the numbers mean if it's number 1, that means leave it white, and if it's number 2, that means make it a little bit dark, but not very dark. Right? So that finishes off the picture, and then we have a moon. So in other words, making a picture of the moon is a fun thing to do. There's many. You get some pencils. right? I use a clipboard when I advise Bear how to make his. So he takes a clipboard outside and lays a piece of paper down on our picnic table. And then he makes a drawing of the circle by watching the moon and carefully recording the information. There's a few things that if you draw the moon, you'll know the moon a lot better than just watching endless pictures of it. But if we do see a picture, we can notice that the moon has two figures on it. This is the dog on the moon. There's the head of the dog and his snout and his body and his front leg and his back leg and his tail. So he's a poodle dog because he has a bushy tail right on the end there. He's a poodle dog. And over here is the man on the moon, his head, his body, his legs, and his backpack. So the man on the moon carries a backpack. I guess he's going to school, and I notice all the kids have these big backpacks. It's like they've got the kitchen sink in it or something like that. I don't know what they've got in it. But anyway, so there's the man on the moon and the dog on the moon. Okay, Bear insists on everyone having a test. Okay, so everyone paying attention. Is this picture the man on the moon or the dog on the moon? You decide. Is it dog? Oh, I see Elena's got her hand up. You say dog, Elena? Yes, she's nodding her head, and everyone else is too. Okay, the dog on the moon. That's right. Yep, your hand is up too. That's good. Edna's doing it too. And I see other people are in agreement. So that's right, the dog on the moon. Little telescopes can be used for this activity, or a pair of binoculars. And that is what I usually do when I go outside to observe the moon. I take a pair of binoculars with me to get a little bit of a close-up on the moon. Okay, now the moon and the Earth, as I mentioned, there they are here. Now they're not the same size. The Earth is bigger, right? Bigger, and the moon is smaller by about that ratio. So they're about like that. There we are, the Earth and the moon. So the Earth is much heavier and bigger than the moon. But even though the Earth is 4 times bigger across than the moon, it's about 80 times heavier, because in the middle of the Earth, it got all sorts of this stuff, iron and nickel, heavy stuff. So the heavy stuff sank to the center of the Earth. So a ball of cement as big as the Earth would be much lighter than the Earth. The Earth is very heavy. Now the moon doesn't have much of this stuff inside, right? Although it was whacked with rocks over time. So the craters on the moon, these round things, they are the impacts of rocks that have hit the moon over time. So rocks have hit, smacked the moon, and left these round depressions. Yeah, and these are some of the things that we draw when we make detailed pictures of the moon. Yeah, that's a lot of fun. Now, oftentimes, people tell me, oh, I've heard about telescopes, and maybe they cost a lot of money and stuff like that, and it's true, but you don't need to really do that. A telescope is simply 2 different types of lenses that are held close together. And I've got one over here. This is one of Bear's toys. This is a lens from a binocular, right? It's with 1/2 of a binocular. Binocular got broken, and sometimes if you look around, you'll see binoculars that are broken, and you can take them to pieces, right? It's not that difficult. Okay, so this is a lens, and the lens goes at the front. Then there's where you look through, the eyepiece. This is an eyepiece. All right, I guess I'll turn that way. This is the eyepiece. So the little glass is where you put your eye. So you look here, and then the lens is at the other end. Now, the first thing you need to do is get a tube to put them in. So this is a tube that I bought for Bear, and it's, there it is. This is plastic tube. It's like the plastic piping in the bathroom. Okay, so it's just a piece of plastic tubing. Now, the lens goes in the front, like that. And then in here, we have more plumbing supplies, including a screw so that we can adjust it slightly. That goes in there, and the eyepiece goes in here, and you have yourself a little telescope. So this is a tiny 8-power telescope, right? Homemade. Now you might say, well, how do you know how long to make the tube? It is critical, but what you do is you take the lens outside and putting a card, you focus the sunlight on the card. Don't look through the lens, of course, but focus the sunlight on the card so it makes a tiny dot, then measure that length. And in that length, it was 20 centimeters, 200 millimeters, or about 8 inches. So that is how long the tube had to be to accommodate the lens and the focal length and the lens at the end for the eyepiece. So with that piece of information, I could make myself a small telescope. And it works really well. I mean, you can see the dog on the moon and the man on the moon much better. Right? There's no doubt about it. 8 power gives you a lot more visibility. You can also see things in it like the Andromeda Galaxy or the Orion Nebula. And star clusters like the Pleiades, everything looks brighter in the telescope than your eye does. So you see many more stars than you would ordinarily. Okay, so the pretend telescope or the homemade telescope gives us a better look at things. But the most important thing is the fundamentals. And the fundamentals means the constellations. So we go outside with our star wheel, right, and begin hunting down the constellations. See that the stars aren't just together as a sort of a mass. They make patterns. So there are squares and are triangles. They're little almost as circles. There's a W in the sky. The Big Dipper looks like a bear, although Bear says it doesn't look like a bear. So there you go. Bear disagrees. It's one of his hobbies to disagree with me. Okay, there we go. Where's the Big Dipper? Bear, where's the Big Dipper? We're not going to lose it, are we? Oh, here we are. Okay, so it's at the very top. So the Big Dipper is right over here. So it's 4 stars that make a bowl and 3 that make a handle. The 2 end stars point to the North Star, which is over here. Now, if you follow the handle of the Big Dipper, it forms an arc, and it arcs down here to this bright star Arcturus. So that's something you can look for right away. As soon as it's clear out, go outside and find the Big Dipper. The handle of the Big Dipper arcs and points down to the ground. It points in the ground direction. But at the end of it, in the springtime, like now, a bright star comes up. It's Arcturus. It's very bright, and it's orange in color. So it is the bright star of the springtime, and tells everyone that the spring is here and is going to be with us for the next little while. So the star Arcturus dominates the sky in the spring and the summertime. And I often see it when I'm out with my telescope looking around, and Bear does too. Don't you, Bear? Don't you see Arcturus in the sky? What do you mean, no? Of course you do. You saw it yesterday, didn't you? Okay, Bear is agreeing. Okay. Okay, so did anyone have any questions? I wanted to ask any questions. Oh, I see someone has their hand up. I see their hand up. Edna or Edda. Do you have a question? Okay. Oh, I think, are they typing away a question here for the oh.
How do planets form?
Very good question. Planets form in the same way that the sun and the earth formed. A big cloud of gas gets together and everything shrinks to get smaller and smaller. As the objects get smaller, they get hot inside. And so if it's a star, the heat will be so great that it will become burning, and then you got a star. But if it's smaller, then it will be a planet. So that's why the planets are hot inside. The Earth is hot inside, which is why there's lava that comes out in volcanoes and things like that. So they all form like that, and you can get the most stuff into the littlest space if it's round like a ball. So that's why the planets are all round, not square or something like that, or triangle. That would be silly. They're all round. The Earth, the Moon, and the Sun, and everything else is round too. So the planets formed like this, and then when they formed, they began to go around the Sun in paths called orbits. So an orbit is a path or a trip that a planet makes around and around the Sun. Okay, so I'm seeing a question here. When we see photos of space, have colors been added, or what do nebula and galaxies actually look like? It's a very good question. Oftentimes, the pictures from space look kind of orange or reddish, but that is because the camera can look at any wavelength of light. Your eye doesn't. So the things that look red in space photos usually look like smoke or fog or colorless. So they're kind of colorless, although sometimes a bit of blue can be seen, but generally colors are added in the photos because the photo people either think it makes them look more attractive, or it's just a custom or a habit that they've gotten into. Just like the media have a habit of reporting the same thing over and over again infinitely. So the answer is you wouldn't see as much color if you were there. It would look like smoke, and that's what it looks like even in my big 16-inch telescope. The second question is, does every star we see have a solar system around it? Well, that's a very good question. I don't know. Many do, but probably not all. So some stars are solitary, but many have solar systems going around them. And so it seems that the solar systems are not rare or unusual, but are very, very common indeed. And this was the suspicion of astronomers, but it couldn't be proved. And then in 1995, the first system was found. And then since then, many, many others, thousands of others. So we know that it's common, but this is not a surprise really, because astronomers realized that not all objects that form would be stars, but there must be many, many planets too. So the planets show up and we can now find them. It's important to remember that even though they're identified, we can't really go there because taking a trip there, I mean, like there's no bus to get you there, right? You can't take the sky train. So there's really no way to get to these places. Their distances are very remote. So the planet Mars is very close by compared to the distances to extrasolar planets. Okay, I've got two good questions. Any more? I see a few hands up there. Does someone want to lead off with a question?
I see Elena and Everly.
Yes.
Who shall we call on first?
Okay.
Maybe, I think I saw Elena's hand up a little earlier. So
Okay.
shall we take your question first, Elena?
Okay.
And then Everly?
I have 4 questions.
Okay.
When did you say is the meteor shower?
The meteor shower is in August, around the 12th of August. That's the Perseid meteor shower. Yeah, 12th of August. Isn't that right, Bear? I'll just get Bear. Bear's saying that's right. Okay.
Do they count Pluto as a planet anymore?
That's a very good planet question. No, they don't, because it was found out Pluto is really, really tiny. Pluto is even smaller than the moon. So because of that, it was dropped from the list of planets. It was only on the list when it was thought that it might be much bigger, but that wasn't the case. So Pluto was a planet from its discovery in 1930 to the year 2006 when it was dropped. The fellow who discovered Pluto was Clyde Tombaugh, and I once had a telephone conversation with him from his home in Arizona. We talked about astronomy and things like that. So that was sort of an interesting moment to talk to someone who discovered a planet, although the planet was dropped. Okay. All right.
What subjects are the most important to study to be an astronomer?
Well, that's a very good question. Physics and mathematics are the two leaders, okay? So the astronomers are people who are good in physics and good in mathematics. So math is really a lot of fun if it's tackled the right way. So yeah, those two things, physics and math. sometimes astronomers are called astrophysicists. So because they use mathematical tools to investigate. Now, another question might be, where would we get more information about astronomy? And the best place to get information on astronomy or any other topic really is the public library. Yeah, guess what? So you go to the library, the books in nonfiction have numbers on them, and 523 is the call number of astronomy. So walk through the nonfiction section and look at the numbers on the books and stop when you get to the 520s, and then look closely, you'll see astronomy books. Okay, we have another question.
Everly had her hand up for some
Everly has
time.
her
Shall
hand up.
we?
Okay. Everly, your turn. I think
You're muted, my dear.
Yeah. Okay, good. I don't think you're speaking into the microphone.
Why don't you try typing your question in, and maybe Bill will answer another question while you type your question into the chat. Okay, Everly?
Okay. The scene from the, I've been outside the Trotry Observatory, but never seems to be open to people. I think that the Trotry Observatory at SFU, if I remember correctly, it's open on Fridays when it's clear, and it's open by volunteers. So it doesn't have a staff that are paid to be there. They're volunteers from the Royal Astronomical Society of Canada. And so the best idea is to contact them first, go on the SFU website, and then phone first the number to make sure the observatory is open. And it's usually a Friday. That seems to be the day they pick. But often you get rain on Friday, so then you're out to lunch. It has to be clear or the telescope can't see anything. Okay. Are we made of stardust? Well, actually, yes, the answer is yes. What happens is the things that are inside of us, and even the things inside Bear, are made out of things that were made inside stars. So stars percolated out the elements, chemical elements that make up the things in the earth and on the earth, and even living things as well. So carbon, magnesium, oxygen, phosphorus, all the elements of the periodic table were made inside stars. So I'm made out of stars, so are you. Everyone is, even Bear. He's made of, Bear says, no, I'm not made out of stars, I'm made out of bear meat. But bear meat was made inside stars, Bear, so get with the program. Okay, so that's a good question. So do we have any more questions? Are we, oh, I see a space book. Yeah, that's a space. Are you holding up that space book there? Yeah, it looks like a good one. But as I said, space books can be found at the library. So my advice is to further your knowledge of astronomy, take a visit to the library. I'm assuming the library is open to the public now that.
Oh, yes.
Yeah, okay. So as I say, nonfiction, what's the call number we're looking for? 523. Okay, well, I guess we've about run out of time. Well, I have to sign off, and thanks everyone for coming. And Bear had a good time too, didn't he? Thank you, Bear, for your wonderful artwork. Okay.
Everyone, thank you so much for coming. And I know we had so many really good questions too. And remember, you can always come to the library, and as Bill said, and we can find answers to all of your space questions. Thank you for being here and taking the time out of your afternoon, Bill, to tell us a little bit about space. And I, for one, am very excited about these 10 things to see in the sky for the next year. I hope that I did put in the chat, everybody, a link to the H.R. Macmillan Space Center's Star Finder, which you can print out, and it looks exactly like the one that Bill was showing us. So maybe we'll go out in the summer, in summer reading club, and go look at the meteor shower or something, eh?
That's a great idea. Yes.
All right, everyone, have a wonderful rest of your afternoon. We are out of time, and we will see you again, hopefully very soon at the library.
Okay.
All right, everyone, bye.
Bye-bye.